This is Yelena. I will be presenting the one variable chi-square test. We'll be testing for the goodness of fit. The chi-square quantifies the probability of chance of qualitative data. The statistic answers the question of, is there a relationship between the two variables, or is this by chance? There are two types of chi-tests. The one sample test determines whether or not the observation was by chance, and it looks at only one observation. The two-variable chi-test determines if there's a relationship between two variables, or whether it's just the two were observed by chance. When calculating chi-square, we're looking for alpha 0.05, meaning that the data would have occurred 5% of the time. Anything over 5% can be attributed to chance. The degrees of freedom represent the number of possibilities and is calculated by the number of categories minus 1. And the critical value determines the boundary for rejecting or accepting the hypothesis. The critical value is a factor that's used to compute the margin of error. The formula for chi-square, represented by an italicized x squared, is the sum of observed phenomenon or observed values minus expected values squared over expected values. We will be looking to determine whether the null hypothesis is accepted or rejected based on the data we've collected. The null hypothesis states, being born during a specific season will influence a person to develop seasonal allergies. We have observed data for people born in the spring, summer, fall, and winter. We also calculated the expected data. So to demonstrate the data distribution, the observed data is in blue, so it's kind of spread out throughout the entire chart. The expected data equally distributes the number of people per each category. This is how we're going to determine the variance between what's observed and what's expected, and whether or not this variance is due to chance or if there's an actual correlation. Okay, so we're looking to determine if being born during a specific season will influence a person's probability of developing seasonal allergies. We've collected data from people who suffer from seasonal allergies, and we've categorized them by their birth month. These are the data that were observed. The next step is to determine what data was expected. So the way to do that is to calculate the sum of the observed. So we had 61 individuals participate, and divide it by the number of categories, which in this case is 4. So you do that by going 61 divided by 4. And this is our expected value. So you just take that and you put that into every single category. The next step is to determine the differences between values observed and values expected. And you do that by taking this cell and subtracting it from this cell, or vice versa. I'm sorry. Then you can just click on the cell and expand the formula to all 4 categories. The next step in determining the chi-square is to figure out the differences squared. So you do that again by selecting the difference and squaring it with a caret. So this is the difference squared. And again, select the cell and extend it to all of the columns. Finally, the last step in determining the chi-square is to divide the square difference by the expected value. And again, take that and expand it across all cells. So now we've determined that our chi-square is 30.74. Our degrees of freedom is 3. Again, degrees of freedom is calculated by taking the number of categories that you have and removing 1. Degrees of freedom value the number of possibilities that can occur. And we're looking for 95% confidence, meaning that we're looking for an alpha of 0.05. So we will only determine that this is an actual correlation if the alpha is at 5%. So the chances of this happening are 5% of getting these numbers. The critical value, which helps determine the statistic at which point would determine whether or not this is a correlation, or if this is just by chance, is 7.04. So again, the critical value computes the margin of error. So the idea is x squared should be 0, or as close to 0 as possible, or the critical value. After the critical, or anything higher than the critical value, indicates that the observed phenomenon just happened by chance, and there was no correlation between, being born during a certain season and getting seasonal allergies. So this would actually make the reject the null hypothesis. If for some reason the chi-square fell below 7.8, then we would accept the null hypothesis, saying that being born during a specific season will influence seasonal allergies. And that's that. So the result of the chi-square test was 30.74. The degrees of freedom was 3, and our alpha was 0.05 with a critical value of 7.814. Because the chi-square fell significantly above 7.814, we can safely say that the null hypothesis is rejected. Had the chi-square fallen below 7.84, we would have agreed that the null hypothesis was true and should have been accepted.